Hey guys, Tom at Snake River Base, and I want to talk a little more about ground speed and airspeed as they affect your canopy in flight. Okay. Last time, in the last 3 videos, we talked about airspeed and ground speed in different cases. Jumper on the ground, excuse me, jumper on the ground, jumper in a hot air balloon, and jumper under canopy. I want to point out first that the 2 cases that are most important for understanding flight mechanics are the bottom 2. In these cases, you're an aircraft. In this case, you're connected to the ground, you're not an aircraft. Now, it's interesting to note that a base jumper deploying their parachute is usually up here in this box. On a short delay slider down jump, you're not yet part of the wind block and you do have to worry about the crosswind on deployment. But right now, I just want to talk about canopy flight mechanics. So what I'm going to do is I'm going to erase this, and we're going to talk about airspeed of a canopy in flight and how the wind affects it. Now remember that over here, we have a 15 mile per hour wind going that way. And over here we have 0 wind. Here's what I want to know. If I'm coming in downwind or upwind, do I have to flare higher? Do I have to flare lower? Do I have to flare sooner? Do I have to flare later? How about my canopy's turn response? When I pull the toggle down, does it turn slower going into wind or slower going downwind? How does this affect my canopy's flight mechanics? Because that's going to be really important to us. The first thing we learned was that airspeed doesn't change with the wind. And that answers our question. What is it that's making your canopy fly in the first place? Well, it turns out that your parachute is a wing. And we can draw it as a wing, right? Here's my airfoil shape. What makes this wing fly? What makes it fly is airflow. Air strikes the front edge, separates, and moves past the wing. In a very simplified sense, what happens is the air separates and reconnects at the trailing edge. And when it reconnects, magic occurs. What you see is that this dead Italian guy, his name's Daniel Bernoulli, rises up out of the grave with a magic wand. And he waves his magic wand, and presto, he generates what we call lift. So this airflow over the wing is the thing that generates lift. And that's the thing that makes our canopy fly. Why does that matter to us? Because it's also the thing that makes our canopy turn and flare. Because changes in the lift generation are what makes the canopy turn and flare. So the question is not, how does the wind affect the turn and flare? It's, how does the wind affect the lift generation? When the wind changes, how does it change this air across the top surface? Well, that's an easy question to answer too. Because when the wind changes, how does it affect the airspeed? The airspeed is the relative movement of the wing through the air. And when the wind changes, does it affect the airspeed? Well, let's see. If my wind was 0, the airspeed was 15. If my wind was 15 and a tailwind, my airspeed was 15. If my wind was 15 and a headwind, the airspeed was 15. It turns out, and this is critically important, that wind does not, I know my writing's bad, does not change airspeed. The reason that matters is because it means the wind doesn't change how the canopy flies. The wind does not change how the canopy flares. The wind does not change how the canopy turns. Turn, flare, stroke, control, those are all the same, whether there is 0 wind, whether you're flying downwind, whether you're flying upwind. So a lot of people at the drop zone will tell you that if you're flying in downwind, you have to flare later or earlier, I don't know, something. Or if you're flying in upwind, you have to flare later or earlier or whatever. And that's just not true. It turns out, because wind does not change airspeed, wind does not change turn or flare characteristics, which means that your flare and turn are exactly the same, no matter what the wind is doing. Whether you're flying downwind, upwind, crosswind, or no wind, what you do is exactly the same. The only thing that changes is your ground speed and which way and how fast you have to run out after you touch the ground. The reason that this fools a lot of jumpers is because we're looking at the ground, and the sliding ground picture freaks us out. Try not to freak out and flare as normal.